Okay, Calc girls, I am going to give the answers to the homework that I have assigned right now, the review of problems from AP tests on slope fields and differential equations. So if you get stuck, you can look at something here and see if it can help you. Don't just, this is up to you now. You're gonna have to take responsibility for your own learning. So the answers are going to be here, but you maybe want to just get some little hints and then turn it off and see if you can do some or whatever you think is best for you. You're going to have to decide. So for the first one, it is the first one is the 2004 AB 6 no calculator. This one that I have written here, and you have to write the draw the slope field. So let's see, when x is 0, it's going to definitely have a slope of 0. Whoops, that was wrong. When x is 0. So there's going to be zeros all here. Right here, when x is 1 and y is 0, if it helps you to make a little chart, you can. When x is 1 and y is 0, then the derivative is 1 times -1, which is -1. So it's going to look like this. When x is 1 and y is 1, it's going to be 0. When x is 1 and y is 2, it's going to be 1 times 1. It's going to be +1. When x is 1 and y is 3, it's 1 times 2. So it's 2, so it's a little bit steeper. -1, 1, they're going to be the same because x is squared. So -1 squared is 1. So it's going to be 1 times -1. That's -1. And these are also going to be can't do this. The same. So there is the slope field for that one. Then it says, while the slope filed in part A is drawn at only 12 points, it is defined at every point in the XY plane. Describe all the points in the XY plane for which the slopes are positive. So we want to know, when does this greater than 0? So I would write like, you would solve basically for, oops, that was wrong. Solve for y. So we're going to divide by x squared, which is still 0. So y greater than 1. All the points where y is greater than 1, the slopes are positive. Anything where y is less than 1, the slopes are negative. It doesn't matter what x is because the x is squared, so that's always going to be positive. So that's how you would describe that right there. All right, we're going to move on to the next free response, which is the 2005 AB6 no calc. Okay, dy over dx equals -2x over y. And we go up to 2 and down to -2. And the points are 12 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you need to go ahead and draw this this slope field for these 12 points. So let's see, at 1, 1, this is going to be -2 over 1. So it's going to be a -2. And I'm just going to do these. I'm not going to write out all of them. You can figure these out. I'll do one more at 1, 2, it's going to be negative 2 over 2. It's going to be negative 1. So it looks like this. And over here on this side, it's going to be the opposite. And down here, it's going to look like that. So that's what the slope field looks like. And just so you know, if you want to know how they score these things, this is how they used to score them. I don't know if it's going to be any different this year. For this problem, you would get 1 point. Because I forgot these in the middle. Anytime x is 0, the slope is 0. You get 1 point if you show the 0 slopes, and you get 1 point if you show the non-zero slopes. So that's how they're going to score this part A. Part B, let y equal f of x be the particular solution to the differential equation with the initial condition f of 1 equals negative 1. Write an equation for the line tangent to the graph at 1, negative 1, and use it to approximate f of 1.1. So that's what we're doing right here. So we need to write in an equation of the tangent line. You need a point, which you've got right here, and you need a slope. And your slope is a derivative, which is this. So we're going to find the slope of our tangent line. We're going to take the derivative, and we're going to substitute 1 in for x and negative 1 in for y, and we get 2 for our slope. So to write our tangent line, we're going to have y plus 1 equals 2 times x minus 1. There's our tangent line right there. You can leave it like this. I'm actually going to change it just a little bit for the approximation because it's easier. Either one of these is fine, and you would get 1 point for the tangent line equation. Then we go ahead and find the approximation, and f of 1.1 is approximately 2 times 1.1 minus 1 minus 1. Okay, now if you notice up here, this was a no calculator problem. So they expect you to be able to do these things right here without a calculator. 1.1 minus 1 is 0.1. This is 0.2 minus 1 equals negative 0.8. That's your approximation right there. You get 1 point for that, for finding that approximation for part B. All right, so part C says, find the particular solution of y equals f of x with the initial condition f of 1 equals negative 1. So now we have to actually separate the variables and solve the differential equation. So we've got dy over dx equals negative 2x over y. So we're going to separate the variables. I'm going to bring y over to this side and dx over to this side. Since y is already on the bottom, it just becomes y dy equals negative 2x dx. This is an easy one, no ln's. Take the integral of both sides, you get y squared over 2 equals negative 2x squared over 2 plus c. Okay, you don't have to write the 2's here if you can do that all in one step. So this would be y squared over 2 equals negative x squared plus c. And we're trying to solve for y, so you can do two things. You can solve for y right here and then find c, or you can find c right here and then solve for y. I'm going to find c right here because I think it might be a little easier. I'm going to substitute negative 1 in for y. I don't know why I switched colors. And I'm going to put 1 in for x, and I get 1/2 equals 1 plus c, and c equals negative 1 plus c, sorry about that. C equals 3/2 or 1.5. Now I'm going to put it back into my equation, and I get y squared over 2 equals negative x squared plus 3/2. And I'm going to solve for y. Y squared equals negative 2x squared plus 3. And y equals plus or minus the square root of negative 2x squared plus 3. But up here, what does y equal in our particular solution? Y equals -1. So that means we have to choose the negative, and our answer will be y equals negative the square root of negative 2x squared plus 3. And that is the answer to the particular solution. So for this, here's how the points divide up. You'd get 1 if you separate the variables. You get 1 to find the antiderivatives. Okay, so you got 1 for having this. You got 1 for having this. You got 1 for the c. You get 1 whole point for putting your c in there. You get 1 if you substitute in the initial condition. And you get 1 to solve for y. So you can see that if you went all the way through and you stopped like right here, where you just had y squared, or even right here, you would just miss this 1 point of solving for y, but you would have gotten everything else. So that is how you do that problem. Let's look at the next one. Okay, we've got, this is 2007 Form B, AB 5. Again, it's a no calc, but I really don't know how they're going to have you do that this year. So dy over dx equals 1/2 x plus y minus 1. Okay, on the given axis, 9 points. You can see that most of the time they don't have you do too many points. And let's see what this looks like. I have the answers here in front of me, so I'm just going to draw it. You can go through and see. This one is negative. This one, let's see. That's probably, I'm going to erase that. That's probably even a little more flat. -1. This one's a little more. Okay, something like that. What the slope field looks like. For this, you get 2 points if you get the sign of the slopes. So as long as you have positives where they're positives and negatives where they're negatives, and the relative steepness. So as long as it gets steeper where it needs to, or less steep where it needs to, you get to find the second derivative in terms of x and y, and describe the region in the xy plane in which all the solution curves of differential equation are concave up. All right, so first of all, let's find the second derivative. That is 1/2 plus dy over dx. Okay, the derivative of this is 1/2. The derivative of y is 1 times dy over dx. This is implicit differentiation. The derivative of this -1 is 0. So here's our answer, except it asked us to find it in terms of x and y. So we have to substitute in what dy over dx is to find the second derivative. So here's our second derivative in terms of x's and y's. Well, actually, we could put the 1/2 and the 1 together. So probably a better answer is 1/2 x plus y minus a half. That's a better answer. All right, that you would get 2 points for getting that right there. Then it says, describe the region in which all the solution curves to the differential equation are concave up. You know things are concave up when the second derivative is greater than 0. So we're going to take our second derivative and set it greater than 0 and solve for y. So we get y is greater than negative 1/2 x plus a half. So our description would be solution curves are concave up above the line y equals negative 1/2 x plus a half, or something like that. Okay, you get 1 point for that description right there. Then we look at part C, and it says, let y be a particular solution of f of 0 equals 1. This is C. Okay, there's our initial condition. Does f have a relative max, min, or neither at x equals 0? Justify your answer. Well, you know maxes and mins. Okay, this is the point 0, 1. You know maxes and mins occur when the derivative equals 0 or is undefined. So let's see what the derivative equals at this point. All right, remember that our derivative is 1/2 x plus y minus 1. So at this point, that's 1/2 times 0 plus 1 minus 1, that equals 0. So this point is a critical number, a critical point, because the derivative equals 0. Now, how do we tell if it's a max or a min or neither? Well, in this case, since I already have the second derivative, I'm going to use the second derivative test. Remember that the second derivative equals, what does that equal? 1/2 x plus y minus a half. So at this point 0, 1, this equals 1/2 0 plus 1 minus a half. That is greater than 0. When it is greater than 0, it is a relative minimum. So the point 0, 1 is a relative min because the first derivative equals 0 and the second derivative is greater than 0. Okay, so that tells us that it's a relative minimum. You get 1 point for saying it's a relative min, and you get 1 point for the justification. Now this next part is a little hard. All right, find the variables of the constants m and b for which y equals mx plus b is a solution to the differential equation. All right, so stick with me with this. It's going to be a little bit difficult. So the slope equals the derivative, right? And the derivative is 1/2 x plus y minus 1. So the slope equals the derivative, and we're going to substitute in this for y. So we're going to say the slope equals 1/2 x plus mx plus b minus 1. Which equals, if we put the x's together and the constants together, it equals 1/2 plus m x plus b minus 1. Okay, so in order for the derivative of this thing right here is just m. All right, that's what we've got right here. We have m equals 1/2 plus m x plus b minus 1. Well, that means that this has to be 0 because there's no x's on this side of the equation. So 1/2 plus m has to equal 0. So m has to equal -1/2. And this has to equal m. But we already said that m equals -1/2. So b equals +1/2. That is a difficult one. You get 1 point for finding m and 1 point for finding b. All right. One more. We've got 2006 form B, AB5. Oh, this one I think I didn't even assign to you, but I'm going to show you the answer in case you want to work on it. Okay, dy over dx equals y minus 1 squared cosine pi x. Look at this. This is a complicated equation, and this is a no calculator problem. So first of all, you're going to do your slope field on your points, and I am going to just put them on here quickly for you. These are all zeros, negative, positive, negative, more negative, more positive, more negative. Okay, you get 1 point for 0 slopes, 1 point for all the other slopes. All righty, let's see part B. There's a horizontal line with the equation y equals c. It satisfies the differential equation. Find the value of c. So that means that the derivative of the line y equals c is 0, correct? The derivative is 0 because c is just a constant. So that means our derivative here has to equal 0. Cosine, ooh, I did this somehow. How did I do this? When does this equal 0? This equals 0. What does y equal? Because our line is y equals c. What does y have to equal for this to equal 0? Y has to equal 1. So y equals 1 is the solution to that. You get 1 point for that. And then we have find the particular solution. So this is C. Find the particular solution. The point is 1, 0. So we've got dy over dx equals y minus 1 squared cosine pi x. We're going to separate the variables. And then we're going to take the integral of both sides. So I'm going to think of this right here as y minus 1 to the -2. And the derivative of y minus 1 is just dy. So I can just do that and get y minus 1 to the -1 over -1 equals the derivative of pi x is pi. So I'm going to have to put a 1 over pi in front. And I'm going to get sine pi x plus c. on this side when I take the integral of both sides. So now I need to solve for, I'm going to make this a little bit more simple, and I'm going to write it as 1 over let's see, I'm going to write this as 1 over 1 minus, 1 over 1 minus y, okay, because this is -1 over y minus 1. So I'm just going to switch the bottom so it's not negative anymore. And 1 over pi sine of pi x plus c. And then I'm going to say, I'm going to substitute in my initial condition here, a 0 for y, so this becomes 1, and a 1 for x, so this becomes sine pi. Sine of pi is 0, so c equals 1. C equals 1 here. So I get 1 over 1 minus y equals 1 over pi sine of pi x plus 1. And then I'm going to solve for y. So there's a couple things, there's a lot of ways that you could do this. I'm just going to give you the answer right here. Y equals 1 minus pi over sine pi x plus pi. And that's your answer. So you got 1 point here for separation of variables. You got 1 point for, or no, you get 2 points for the antiderivatives. You got 1 point for the C. You got 1 point for the initial condition, and you get 1 point for the answer. So those are the answers to the differential equations. I'm going to give the answers to the other page too in a separate video.